Okay, let's just jump right in. Have you ever stopped to think about what actually connects your totally mundane morning commute, the crazy stomach-dropping elements of a massive theme park thrill ride, and the absolute engineering marvel that is a commercial jumbo jet? Well, the answer is a technology that operates almost entirely out of sight, yet it literally shapes the physical world we live in. Welcome to today's Explainer. We're diving deep into the invisible muscle of the modern world, hydraulics. Across so many diverse fields, everything from heavy construction to cutting-edge aerospace, pressurized fluid is essentially humanity's secret weapon. It is exactly how we completely bypass the physical limits of human strength. It's how we generate these colossal, unstoppable forces, often in super compact spaces where traditional gears and levers just wouldn't fit. So to really get this, we just need to quickly touch on the core physics making the magic happen, Pascal's principle. The big takeaway here is that pressure throughout a closed system is constant. That means you can take a relatively modest electronic pump, separate it with some small diameter tubing, and generate massive mechanical force on a much larger piston on the other end. You don't need giant, clunky mechanical levers. You just need pressurized fluid, intelligently directed, to do all the heavy lifting for you. Section 1. Everyday rides and safer stops. Let's look at how you interact with this every single day, starting with your car. When you slam on the brakes, you aren't just moving a mechanical pad, you are actively pushing hydraulic fluid. And if you look at the stopping distance data here, it's pretty striking. Modern anti-lock braking systems and electronic stability control, when they're fully integrated with hydraulics, dramatically reduce stopping distances, especially at highway speeds, like 100 kilometers per hour. This seamless fusion of fluid dynamics and smart electronics makes those rapid-fire, split-second adjustments that keep a vehicle stable. It is literally saving lives every day. But hey, it's not just about moving horizontally. This tech is absolutely vital for moving vertically, too. We always hear about high-speed traction elevators and massive skyscrapers, right? But hydraulic elevators are the true unsung heroes of low-rise buildings everywhere. Instead of pulling the car up from above with steel cables, an electronic pump forces fluid into a heavy-duty cylinder to smoothly and quietly push the elevator cab up from underneath. It's an incredibly reliable, low-maintenance, and super energy-efficient setup for everyday use. Now, installing these systems means engineers have to make some critical choices based on the building itself. Take the conventional in-ground jack, for instance. That requires drilling a deep hole straight down that perfectly matches the elevator's total travel height. But what if local safety codes or environmental limits say no way to deep drilling? Well, engineers can easily pivot to a twin-post jack. It's an entirely above-ground two-jack system operating on the exact same hydraulic principles, but it perfectly adapts to those physical building constraints. Pretty clever, right? Section 2. Moving Earth and Building Worlds. Let's scale things up a bit and look at the heavy-duty brute force applications. The sheer versatility of fluid power is just mind-blowing when you look at heavy machinery side by side. On one hand, you've got a hydraulic excavator using immense, concentrated torque to just tear through solid earth and dense rock. Then, on the other hand, modern farming relies on the exact same tech to power complex, delicate agricultural implements. Whether it's dragging heavy plows or running intricate seeders across huge, uneven fields, hydraulics give us both the raw, unstoppable power and the highly versatile control we need to literally feed the world. And the sheer volume of equipment relying on this is staggering. Take skid steers. They are basically the Swiss Army knives of construction. Because they use modular hydraulic circuits, an operator can swap between augers, trenchers, and grapples in literally a matter of minutes. Whether it's a massive bulldozer tweaking the exact angle of its blade, a towering crane extending its telescopic boom, or a massive concrete pump pushing liquid rock through a pipeline, it's all universally driven by fluid power. What's more, machinery like massive wheel loaders operate in some of the absolute most unforgiving environments on Earth. Think deep underground coal mining, heavy waste management, rugged rock quarries. These places demand equipment that can shrug off abrasive dust, brutal vibration, and even explosive atmospheres. Traditional mechanical gears? They'd grind to a halt in no time. But hydraulic systems are fully sealed. They deliver colossal lifting forces while withstanding that brutal day-in, day-out punishment. Section 3. Manufacturing and the Press. All right, let's step off the dirt and onto the factory floor. When you scale this technology up for industrial automation, you truly see its unparalleled power. Heavy manufacturing processes, things like die casting and injection molding, require hundreds, sometimes thousands of tons of sustained clamping force.
I mean, you have to hold heavy steel molds completely shut against the immense pressure of molten metal and liquid plastic. Only hydraulics can deliver that level of sustained, totally controllable force safely and efficiently, right inside the tight footprint of a modern factory. We really can't talk about industrial presses without mentioning a pretty hilarious fun fact. Joseph Bramah invented the hydraulic press way back in 1795. Yet somehow, over 2 centuries later, it's a viral internet sensation. The hydraulic press channel out of Finland has well over 10 million YouTube subscribers who tune in just to watch this centuries-old tech utterly crush everyday items. Bowling balls, diamonds, plastic toys, you name it. It's visually incredible, incredibly satisfying, and honestly, a perfect reminder of the unstoppable force we're talking about here.
Section 4. Taking flight and thrill rides. Now, let's slow things down a second and look up. Commercial aircraft are an absolute masterclass in hydraulic engineering. We're talking life-critical precision here. Everything from dropping that heavy landing gear to the subtle, precise movements of the ailerons, rudders, and thrust reversers relies entirely on pressurized fluid. Aerospace demands actuators that are not only highly precise, but incredibly compact and lightweight. And the kicker? They have to function flawlessly across massive temperature swings and pressure drops while cruising at 30,000 feet. And it's fascinating how that exact same aerospace-grade precision bleeds over into the entertainment industry. When you are strapped into a cutting-edge flight simulator, or you hit an unexpected dramatic drop on a dark ride, you're feeling the direct effects of hydraulic actuators. Engineers use them because they deliver insanely powerful linear motion silently and smoothly. You get all those thrilling, stomach-dropping dynamics without any of the jarring clunkiness you'd get from chains or mechanical gears. That incredible power density is also a total lifesaver when space is super tight, but the physical forces at play are just astronomical. Take London's iconic Tower Bridge, for example. In highly demanding marine and civil engineering setups, hydraulic systems provide the immense, reliable power needed to fight off fierce winds, gravity, and strong water currents. It's exactly how we lift massive bridge decks or turn the giant rudders of cargo ships, all while operating in harsh, constantly wet, corrosive conditions. Section 5. Power, Control, and Resilience. So, we've covered a ton of ground today. Let's distill this down. Why is this specific technology still universally dominant across all these industries? Well, the core advantages are immense. High power density and crazy high torque at very low speeds are obvious wins. But the real game changer? Overload protection. Unlike mechanical systems, where gears and belts will literally just snap or shatter if you push them too hard, hydraulic systems can stall safely when overloaded. By using clever counterbalance and relief valves, the fluid simply bypasses the main circuit. It effectively protects the expensive machinery from destroying itself. That is absolutely huge. And the crazy part is, this technology isn't just sitting still. The future of fluid power is all about fusing traditional mechanical dynamics with advanced real-time electronic control. Right now, engineers are actively integrating smart materials, predictive analytics, and hypersensitive electronic sensors straight into these circuits. It's making modern hydraulic systems faster, way more energy efficient, and incredibly responsive to whatever environmental conditions throw at them. As we wrap up this explainer, I want to leave you with one final thought. Just take a moment to look around your room, or maybe glance out the window. From the heavy garbage truck collecting waste on your street, to the agricultural equipment that harvested your dinner, to the highly refined materials in the very screen you're looking at right now, can you spot the invisible hydraulic muscle that made it all possible? Because once you truly grasp fluid power, you realize it's the hidden force operating all around us, shaping our world every single day.